Scientists have asserted in a daring statement that they have discovered a brand new planet unlike any other known to humanity. This momentous disclosure has sent swells through established researchers, starting a flood of energy and theory. This information has put NASA, a respected organization known for its significant contributions to space exploration, front and center. The planet in question is remarkable not only for its size and peculiar location in the universe but also for exhibiting a phenomenon that has experts in awe: light that appears to be artificial emanating from the planet. This disclosure brings up significant issues. Are we on the cusp of revealing mysteries that could change how we interpret the universe? Could this enigmatic light serve as a warning or beacon that other planets may have intelligent life? The repercussions are staggering, and as we investigate NASA's amazing findings, we may soon come face to face with facts that have the potential to alter our perception of reality itself. In 2007, NASA set out on a mission that would additionally solidify its heritage as a trailblazer in space exploration. The Daybreak space apparatus, a marvel of engineering furnished with 3 cutting-edge particle motors, was sent off with a solitary objective: to investigate some of the most baffling objects in our planetary group. The first step on Dawn's journey was a 14-month investigation of Vesta, the second-largest asteroid in the asteroid belt. The information and images that Dawn sent back to Earth shed new light on this enormous space rock, which had previously been shrouded in mystery. The findings revealed a world of astonishing complexity with a geologically rich surface that spoke of ancient collisions and cosmic forces that gave it its current shape. However, Vesta was only the beginning. Dawn's mission was by no means finished. The spacecraft was given the even more ambitious task of taking a close look at Ceres, a dwarf planet, after completing its in-depth investigation of Vesta. This progress marked a critical achievement in space exploration. Dawn was able to escape Vesta's gravitational pull and set course for Ceres thanks to the ion engine's gentle but constant thrust, a feat that conventional chemical propulsion systems would have found impossible. The spacecraft's slow and steady journey eventually placed it in a stable orbit around Ceres, where it began the next phase of its mission. As the largest object in the asteroid belt, Ceres, which was discovered in 1801 by the Italian astronomer Giuseppe Piazzi, holds a special place in astronomy history. Initially celebrated as the smallest known dwarf planet, Ceres was renamed in 2006, further fascinating researchers and space experts alike. Ceres is not only the largest but also the most massive object in the asteroid belt, with a diameter of about 950 kilometers. Researchers have long been intrigued by its distinctive features, which set it apart from other celestial bodies in the area. As Dawn approached this mysterious world, the scientific community eagerly anticipated the first detailed images of Ceres' surface. Every expectation was surpassed by what they discovered, particularly within a vast crater known as a crater. The images revealed a surface dotted with bright spots, immediately captivating scientists who were intrigued by these bright spots that appeared like beacons across the dark, rocky terrain. This discovery ignited a flood of hypotheses. What could these brilliant spots be? Before Dawn's mission, the Hubble Space Telescope's best images of Ceres were blurry and low resolution. These brand-new high-resolution images promised to reveal secrets that humanity had been unable to discover for centuries. One of the primary objectives of the Dawn mission was to improve our understanding of the planet's formation, particularly the role water played in the advancement of planetary bodies. The bright spots on Ceres appear to be made of highly reflective materials, possibly salts formed when water was sublimated. A groundbreaking theory emerged as a result of this revelation. Ceres might be experiencing cryovolcanism, a process in which volcanoes erupt with water or brine rather than molten rock. This possibility suggested that Ceres might be geologically active, which contradicted previous notions about this tiny planet. As scientists continued to examine the bright spots, the mystery grew more complex. What precisely were these lights and what did they uncover about Ceres' geography? Could they indicate ongoing geological cycles or perhaps something even more exceptional? These inquiries fueled a new wave of research as scientists sought to unravel the secrets of this far-off world. Ceres distinguishes itself from other objects in the asteroid belt not only by its size and mass but also by its extraordinary composition and the potential presence of water and ice. Unlike typical rocky asteroids, Ceres has a composition more similar to a comet, suggesting it could hold fundamental clues about the early solar system. The Dawn spacecraft finally made it to Ceres in early 2015, marking a significant milestone in space exploration after a 2-year journey through space. The images it sent back in stunning detail showed a world once hidden in shadow. The first images of Ceres revealed a surface shattered by impacts, but the bright spots scattered throughout this alien landscape truly piqued the interest of space enthusiasts and scientists. As the quality of the images improved, researchers began to form hypotheses about the origins of these spots. Could they be ice patches catching the sun's rays, or something more unusual? Theories ranged from mineral deposits to signs of cryovolcanic activity, each offering an enticing glimpse into the mysteries of Ceres. Closer inspection revealed that the brightest spot was not a single feature but rather a cluster of distinct spots. The prevailing theory was that these were salt deposits formed when water sublimated, suggesting that Ceres could still be geologically active, with processes capable of bringing water or brine to the surface, where it rapidly dissipates, leaving behind bright reflective deposits. These findings challenged our understanding of Ceres, portraying a dynamic and complex world far more captivating than anyone had imagined. The possibility that Ceres could harbor pockets of groundwater or brine raised significant questions about the potential for life in our solar system. Ceres is a world of contrasts, an icy dwarf planet with a surface that is both rocky and porous. It stands out because of its distinctive composition compared to most asteroids in the belt, which are primarily composed of rock and metal. Its structure, less dense than that of its rocky neighbors, suggests a combination of water ice and hydrated minerals like carbonates and clays. This composition indicates that Ceres contains a significant amount of water trapped within its surface layer, making it more like a comet than a typical asteroid. The dwarf planet is thought to have a unique internal structure, with a mantle rich in water ice that makes up about half of its volume, surrounding a core that may be made of denser materials like silicates. The presence of so much water ice suggests that Ceres might have once harbored liquid water, particularly if its core was heated by radioactive decay during its early history. This internal structure sets Ceres apart from its asteroid neighbors, raising intriguing questions about its geological activity and the role water has played in its evolution. However, Ceres has more surprises in store. This dwarf planet may have formed in a much cooler region of the solar system before migrating inward, as evidenced by the ammonia clays found on its surface. The presence of ammonia could lower the freezing point of water, possibly supporting the existence of surface saline solutions. These findings not only shed light on Ceres' composition and history but also on the larger processes that govern the formation and evolution of icy bodies throughout the solar system. Cryovolcanism, a fascinating geological process, adds another layer of intrigue to Ceres' story. Unlike the usual eruptions of molten rock on Earth, cryovolcanoes on Ceres release substances like water, ammonia, or methane. These substances, which can exist as liquids or gases in the cold environments of space, are expelled from the planet's interior. Upon reaching the surface and exposure to the vacuum of space, the salt water rapidly sublimates, leaving behind reflective salt deposits. These deposits make up the bright spots that have captivated scientists and the general public. The most well-known of these bright spots can be found in the Equator crater, specifically in the Equator 5 region. This region has become a focal point for scientific investigation due to its high reflectivity and the intermittent clouds observed by the Dawn spacecraft. These clouds are believed to result from water sublimation, suggesting that cryovolcanic activity might still be happening, or at least occurred relatively recently on Ceres. In addition to Equator 5, Ceres is home to several other bright spots, each with its own unique characteristics. The distribution of these spots across the dwarf planet's surface suggests that cryovolcanism may be more widespread than previously thought. The presence of these bright spots challenges the prior assumption that Ceres was a geologically inert world. Instead, they highlight its dynamic nature, revealing a planet that is still evolving with active processes that continue to shape its surface. As the Dawn spacecraft acquired more detailed images, a wide variety of surface features on Ceres began to emerge. The dwarf planet's surface is pockmarked with craters, each telling a part of Ceres' long and turbulent history. From these craters and the bright spots, scientists can learn a great deal about the processes that have shaped Ceres over billions of years. As we continue to investigate Ceres and unravel its mysteries, we are reminded of the vastness and complexity of our solar system. Every revelation brings us one step closer to understanding not just the history of Ceres, but also the broader processes that have shaped the solar system we inhabit today. The groundbreaking findings from the Dawn mission have expanded our knowledge of Ceres, challenged our understanding of planetary formation, and raised important questions about the possibility of life in the universe. As we continue to explore the cosmos, who knows what other shocking discoveries await us in the far reaches of space?